So today we're going to cover Chapter 9, which takes a look at two sample type problems. And so essentially we're comparing two population means, large and independent samples. So what do we mean by that? Samples from two distinct populations. We consider them to be independent if each one is drawn without reference to the other, meaning there's no crossover whatsoever. So, we might be testing in the state of Massachusetts versus the state of New Jersey. No crossover there, okay? The goal is to use the information in the samples to estimate the difference, all right, in the sample mean 1, sample mean 2, in the means of the two populations, and to make statistically valid inference about it. So this next slide here just kind of shows a picture. We have population 1, we could call it different states, right? Massachusetts, New Jersey, population 2, different mean, different standard deviation, sample size would be one, sample size of another, right? Sample mean, sample standard deviation, okay? So populations, samples are subsets of that, okay? So in order to compare these two things, the first thing that we need to do is figure out what is the interval. So the comparison of two population means, large independent samples, we could figure out based off of a confidence interval for the difference between the two population means that happen to be large and independent. Large being the number we're choosing is greater than or equal to 30 samples there. So in order to do that, we would take our first sample mean, subtract it from our second sample mean, and we're gonna add and subtract that to our z-score here. Now our z-score is then going to get multiplied by, this is something new, the square root of s sub 1 squared, all right, so the standard deviation squared divided by the number of samples, right, plus the standard deviation of the second sample squared divided by the sample size of the second grouping, and then we take the square root of that, okay? And we already talked about this. In order for them to be large, they have to be greater than or equal to 30, okay? So here's an example for us to work through and compare. So essentially, to compare customer satisfaction levels of two competing cable television companies. 174 customers of company 1, that represents your N, right? And 355 customers of company 2, okay? Randomly selected, and we're asked to rate their cable companies on a 5-point scale, with 1 being satisfied and 5 being most satisfied, so 1 being least satisfied, I'm sorry. The survey results are summarized in the following table here, right? So this is our number we're pulling through. This is our sample mean, right? This is our sample mean here. Standard deviation, size. All right, so what they want us to do is construct a point estimate and a 99% confidence interval. All right, 99% confidence interval for, these two means, right? Here we go. The difference in average satisfaction levels of customers of the two companies as measured on this 5-point scale. So the very first thing we need to do is plug in what we know, and we need to first calculate what our point estimate is. So basically we're going to subtract that 3.51, which is the mean of that first sample, right? And then from that 3.24, and we get 0.27, okay? In words, we estimate that the average customer satisfaction level for this company is 0.27 points higher, all right, on this 5-point scale than it is for company 2. Okay, that's a pretty simple understanding there. So now we're using the same technique used in Chapter 7 to arrive at the confidence interval, but we're using a slightly different formula here. So we go ahead, we plug everything in, and once we plug everything in, notice the 99 ends up being, so this is going to be alpha divided by 2. Alpha is going to be 0.01, correct? And that 0.01 divided by 2 is going to be 0.005. So we're really evaluating our z-score at 0.005 here when we plug into our table. So that's essentially where this number comes from, right? We're getting this number from a table, and then we're getting these values by plugging in what we know, and we get our confidence interval here, okay? So that's the confidence interval for those two paired samples. So now we need to do the comparison of two population means, large and independent samples. So the null and alternative hypothesis will always be expressed in terms of the difference of the two population means, right? And remember, when we're subtracting them, if it's less, right, then we're dealing with a left-tailed test. If it's greater than, then it's a right-tailed test. If it's not equal to, then we have a two-tailed test. Okay, so in this case here, we have a formula that we're going to use to calculate our z-score. So the standardized test statistic is what we're calculating here for the hypothesis test concerning the differences between two population means that happen to be large independent samples is calculated from this. And like we said, it's large if it's greater than or equal to 30, and it has a normal distribution because we are using z. Okay, so if we want to, take a look at the confidence interval for the difference between two population means that are small and independent, the difference here is that instead of using z, we're using t, and we have to use this formula as well, okay? And this represents the standard deviation squared sub p, which is this here. We plug in, our two different values, our two different standard deviations, our two different population sizes, sample sizes that we're working through. And then we also need to figure out what the degrees of freedom is. So the degrees of freedom for something like this, typically you would go ahead and subtract one from if you're doing an individual sample. But right now, since we're comparing two samples, our degree of freedom is we add the sample sizes together and we subtract 2 from that. And you remember, small means it's going to be less than 30, okay? So we have a couple new formulas here that we have to remember and know that this only falls for small independent samples, okay? And so we also have our standardized test score, standardized test statistic for hypothesis testing concerning the difference between the small independent. So this is going to be slightly different here. This is also the same, all right, but this is going to allow us to figure out what that t-value is. And at the end of the day, what we're doing here is we're going to compare this value, right, to the value that comes out here, okay? We want to see if that t-value right here does in fact fall within the range or within the interval that we get in this comparison right here, okay? And then the comparison of two population means, paired sample, the standardized test statistic for the hypothesis testing concerning the difference between two population means is a paired difference sample here, okay? Where D with a line over it is the mean and S sub D is the standard deviation of the difference, okay? So what I'm going to do right now is I'm going to run you through an example of one full problem here with hypothesis testing and all that in relation to chapter 9. And then if you can accomplish this, then at the end of the day, you're really going to be able to handle what we're throwing at you when it comes to chapter 9.